I trust that you've had a chance to try some of these questions on your own. Let's take these up before we move on to the next examples. Okay, we have the third root of 64 raised to the power of 2. Okay, so this one, our third root of 2 to the power of 6, all raised to the power of 2. Okay, we're going to simplify again. So third root, 2 to the power of 12. And then as a power form, we have 2 to the power of 12 over 3, and it simplifies to 2 to the power of 4. Part B, 9 to the power of 3 over 2. This is the square root of 9 to the power of 3. Now I know that 9, square root of 9 is equal to 2. So I'm going to do the square root of 9 first. We have 3 from this square root to the power of 3. Part C, 32 to the power of 4 over 5. This is equal to the fifth root of 32 to the 4. So the fifth root of 32 could also be written as the fifth root of 2 to the 5. So that would all be raised to the 4, but since the ra- um, the exponent of the radicand is the same as the index, those kind of cancels itself out, and I'm left with a 2 to the power of 4. Last one here, 216 to the power of 2 over 3. Okay, so let's take 216 and prime factorize it. 2 goes into it 108 times. 2 goes into 108 54 times. And then we have 2 and 27, 3 and 9, and 3 and 3. So what we have is 2 to the power of 3 times 3 to the power of 3. That's one way to look at it. Another way would be to combine these so that we have a base 6 instead. So with base 6, we would have 6 to the power of 3. Either way works. This is a prime factorization, but this one we've also made it into a power as well. Okay, so we get third root of 2 to the power of 3 times 3 to the power of 3, and all of that is raised to the exponent 2. Now, remember the distributive property. I can do that with this as well. I'm going to first simplify the 2 to the power of 3. The exponent and the index, they divide out. So, or sorry, they cancel out. So we have remaining 2, and then the 3 cubed, and the third root of that, that gives me a remaining 3. And all of it is still raised to the power of 2. Now simplified, that gives me a final answer of 6 to the power of 2. Now what about having negative bases? Consider this. If I had negative 2 to the power of 3, that would mean I have negative 2 times negative 2 times negative 2, and that's equal to negative 8. Now, if I'm going backwards, is it possible for me to have the third root of -8? Yeah, that would be possible because the index tells us how many times we have to multiply the base together. So if the index is an odd number, then it's possible to have a negative radicand. So if you have an odd number of negative numbers multiplied together, it's always going to give you a negative product. Now consider this. What if you have 2 to the power of 2 is equal to 4? If I have -2 squared, this is also equal to 4 because +2 times +2 is 4, and -2 times -2 is also 4. So is it possible for us to have the square root of -4? The answer is no, because when I have a, an even index, so in this case, this is the implied 2, then it's impossible to ever have a negative radicand. Why? Because an even number of negatives multiplied together will always give you a positive product. Right, so we have some examples now where we have a negative base. -32 to the power of 2 over 5. So we have the fifth root of -32 raised to the power of 2. Now I put that into a bracket because the negative is also raised to the 2. Now let's simplify here. I have the fifth root, and -32 is 2 to the power of 5, all raised to the 2. So we can simplify this because we know that if I have an index and an exponent in the radicand the same, they cancel each other out, and I'm left with the radicand. So -2 to the power of 2. We could simplify that to equal 4. Hey, another example, -8 over 24 to the power of -1/3. Now, when we have a negative rational exponent, let's switch that into a positive exponent first. And then one more note, I have -8 over 27. This is the same thing as saying -8 over 27, or I can write it as 8 over -27. So the negative sign can go with either the numerator or the denominator, but never both of them. Okay, so let's simplify. I'm going to make this first a positive exponent, positive exponent by flipping the base. Negative 27 over 8, all to the power of 1 over 3. So I have the third root of negative 27 over 8. So it doesn't matter which one I would like to put the negative with. I'll simplify that and put it with my top. So cube root, I have negative 3 to the power of 3, all divided by 2 to the power of 3. Now, since both of these radicands have the same index, um, the exponent is at the same as the index, I know that they cancel out. So my final answer is negative 3 over 2. Slide number 16. Try these on your own. Please pause the video so that you can try it, and I'll take this up in a bit. Okay, let's take this up. We're going to first rewrite this as a radical. I have the third root of negative 1,000. We've got an odd index, so I know it's possible for us to solve this if I had a negative radicand. Now, when I prime factorize negative 1,000, it won't be to base 10. But I know that all of these, any 1,000, 10,000, 100,000, a million, these are all multiples of 10. So even though 10 is not a prime number, I would like to re-express negative 1,000 as base 10. We have the third root of negative 10 to the power of 3. This simplifies to negative 10 to the exponent 3 over 3, or simply negative 10. Right? Negative 8 to the power of 2 over 3. So I have the third root of negative 8 to the power of 2. The third root of negative 2 to the power of 3, all of it raised to the 2. Once again, this part here is the same as the index there. So the only thing left is the radicand. Negative 2 to the power of 2, which equals 4. Part C, 36 to the power of negative half. In order for me to make this a positive exponent, I need to take my base and flip it. So I have 1 over 36, all of it raised to the power of 1 over 2. 1 over 2 means the square root. 1 over 36. Square root of 1 is 1. Square root of 6 is 6. Last but not least, D, negative 16 to the power of 1 quarter. So I have the fourth root of negative 16. But there's a bit of a problem. We have an even index and a negative radicand. There are no numbers that can be multiplied by itself 4 times that will give us a negative number. So this question isn't solvable because there's a negative radicand and an even index.